Hello, my name is Ethan Page, and today we're going to be looking at Project 1 for my GPE340 class, going over root motion. Now, so far I've built a small arena that can be played with here. There's gravity working, there's collisions, all these things work. The character will strafe around if you press the controls, walk towards the mouse, you can walk up these ramps, walk away from the mouse. Left, right, left, right, forwards, backwards, any combination of those things in any direction that you please. I've also coded in a simple little sprint system. If you press the sprint key, then he runs a bit quicker, and this again works in any of the directions. You can sprint backwards, so he's quite agile. And finally, I also got some more animations in and programmed a simple little victory dance. So for now, that's coded to when I press the V key. However, later on, once there is actually a win condition, I'll likely have it play then. But for now, he just dances whenever I press the button. And whenever you press any other button, he goes back into running. Now, as you can see below here, all of these are the animations. They've all been implemented, they all work. I spent a great deal of time making sure they all had the right velocities to go where they needed to go. See different values there. The way that I've got it set is that the character will always run W in the inputs forward, will always run towards wherever the mouse is pointing, and that is done through a few bits of code, which I'll bring up here. So to start off with, we have rotate to mouse position. This is where we use plane.raycast amongst building array, defining the ground plane, stuff like that, to then rotate the character towards wherever the mouse is. The plane.raycast finds with some help, finds the distance between wherever the mouse is with screen point to ray, and defines that point to then grab the character and begin rotating towards that point with quaternion dot look rotation and rotate towards. So then, player rotates towards that point. This then, with the player controller over here, uses, we have a pawn, which I will look into in a moment. Pawn.move, new vector2, an x input and a y input, get axis horizontal and vertical. These are the two names that we have given in the animator, the two variables, float variables, which are passed into the blend tree to determine which animation ought to be played, or which blend of animations. The more positive on the vertical, the character will be running forwards, negative on the vertical, running backwards, and then left and right for the positive negatives of the horizontal. Sorry, right and left, respectively. These are all passed in through this, which then in there, public void move, vector2 direction gets passed in, and it sets the float horizontal to the direction of x times the speed, or vertical to the direction y times the speed. And that allows for the animations to be played and blended in whichever way they need to be in order to get the movement that you just saw. This is also where the sprinting and victory dance is handled, back in the player controller. If left or right shift is pressed, then sprint is true. If the keys go up, then sprint is false, and the same goes for the victory dance key, being V, and this then checks for if any key is pressed other than V, it then sets it false, which then goes in here and simply activates that boolean in the animator. I will show you the animator in a moment, but really quickly, due to the way that this is coded here, simply with the vector2 direction, horizontal, vertical, collected here, passed in, and with the quaternion rotate towards, I have not used inverse transform direction. This would be useful to anyone who is looking to have the character move in a certain direction without having the rotation handled the way that it's handled here. As otherwise, when the character would be rotated by any means, whether it's a starting rotation or something pushes them and turns them in such a way in the game, suddenly when you press W, if you aren't using inverse transform direction, to move forwards, instead of moving forwards you might move forwards and to the right. It can mess with the direction that you run because it only works on global. Inverse transform direction goes to the target's local parameters, which would allow for the rotations to not affect which direction you want it to go outside of how you wanted it to. However, with the way that I've got it written here, I don't need to worry about that. I can mess with the rotation of the player model, which I will as soon as it loads. For example, I can come in here and I can just rotate him like that, and when I press play, he still goes in the direction that I want him to, because he points towards the mouse position. Now, if we have a look at the animator, we'll notice that I've got 4 parameters here. There's the horizontal and the vertical, which go into the tree here. They get passed into these positions, which determine the speeds required to reach each of these animations. And if I press this, and just move there. If I start moving on the horizontal, then it starts moving that way. I can move on the vertical, and that's how that works. So both these back to 0. Now back up to the base layer, we have this dance, as I showed imported earlier. That's if the victory dance is checked, then it will go from either of these into the dance. The sprint is what gets you from the walk-run tree to the run-sprint tree. These are quite similar in that they have a bunch of these animations here. This walk and run has the idle and walk and run animations, as the name may suggest, versus the run-sprint having the run and sprint animations, as well as an idle. That way, if the shift key is pressed, this box is checked and it switches over to this tree and plays those animations instead of this one, allowing for a sprint functionality. Now if we look back at the code, then we will notice that the camera has this follow target function. I have 2 versions in here, the simple one I wrote initially, and then a different one I wrote using a different function, vector3.moveTowards. The simple version simply takes the camera's position and makes it equal to the target's position plus a defined offset. This just constantly ticks over and sets the camera's position equal to that position plus the offset, making sure it's always a little ways away. Now the vector3moveTowards version is slightly more complicated to achieve a very similar goal, however it's a little more versatile. You define a float, and I've called it step here, made it equal to a defined speed in the inspector and multiplied it by time.delta time. This allows me to set up a follow speed that can be altered for varying effects to make a camera follow the target more rapidly or slower depending on what effect you're going for. Thus use in vector3.moveTowards. Make that equal to transform to position, pass in the required parameters, and that step value to make sure the camera tracks at certain speeds. This can be modified again to set up different camera effects if that is what's required. Maybe you want the camera to track a bit slower to prevent people from running too quickly ahead or anything like that. This allows for that, whereas this wouldn't. And now finally I will give one more quick demonstration of the scene, as well as a final little overview of some of the things. Again, it's a simple little mechanic, but I got in the bonus little sprint here. You can run around. There's all these different bits of cover to run between, which once guns are implemented will make for some interesting firefights. There's these walls here that you can shoot over. They're only about waist height, but do block movement. If I go around over here, there's a bunch of these little things to run in between. There's some more walls here that I can run around, take cover behind. There's another set of ramps. This is mirrored to the other side, but with opposing colors, so you know which side you're on. Once again, also has these little waist high. I've got some triangles coming out the ground here for some more interesting cover. Really not great as cover. This will help block some shots, but it's just interesting. And then again with the walls. And then once again, leave you off with a dance. Thank you very much. Again, it's Ethan Page. This is Milestone 1. I'll be doing Milestone 2 shortly, where I will get inverse kinematics up, as well as weapons and other pickups. See you then.